Dear students, firstly I will introduce myself, Professor S.H. Chaube, working as assistant professor in electrical engineering department of S&D College of Engineering and Research Center, Yola. So when we are going to study high voltage engineering, up till now the generation of the high voltages and the current we are going to study. So up till now what we have seen the Tesla coil, we have seen the resonant transformer, we have seen the cascade transformer. What are these? These are going to be used for the generation of the high AC voltage. Now we will come to the point. Now we are going to study the generation of high DC voltages. Generation of high DC voltages. See here the topic. Generation of high voltages and current. Then here is going to be the topics to be covered. Generation of high DC voltages. I hope that you are in the final year students. So even though you are the electrical engineering student, you are well known with the diode, triad, right? So where the diode is going to be used generally? You can easily say that suppose you are going to ask that in a half wave rectifier circuit, full wave rectifier circuit, diode is the main function or the main component of that. Right? So in this case, what we are going to study is that different conventional method for generation high voltage. There are 4 methods are given in this one, which are converting high DC voltage from high AC voltage. First one, half wave rectifier. Second one, full wave rectifier. Third one, voltage doubler circuit. And the fourth one is the cascade and voltage doubler. These are the 4 methods that are used for the generation of the high DC voltage. So step by step, we will see what is the half wave rectifier circuit, what is the advantages, what is the application, why the half wave rectifier circuit is replaced by full wave rectifier circuit. Full wave rectifier circuit. So this is going to be seen. So half wave rectifier circuit, what is the half wave rectifier circuit? Is the simplest form of the rectifier and requires only one diode for the construction of a half wave rectifier circuit. One diode. I have told that. Why diode is called a unidirectional device? It is called as a unidirectional device because it works only in one direction. When it is forward bias, then only then it will conduct. In the reverse bias condition, it does not happen or it does not work. And the same principle is used in the case of half wave rectifier. Why it is called as half wave? Because in this case, only the half of the wave is rectified or converted into DC, remaining half is non-luminous. So it is called as the half wave rectifier circuit. And the main component of this one is the diode, transformer, and the resistor. What are the main components? Diode required, transformer required, and the resistor load is required. So see here in the diagram. Each here supply is given, the primary winding, secondary winding, diode, load. See here. This is supply, primary winding, secondary winding, step down transformer is used here. Here is a diode, here is the load. What is a step down and step up? You are the B electrical final year student, so it is not necessary or does not be essential to state that what is step down transformer and step up transformer. In a step down transformer, voltage is reduced from higher voltage to lower voltage, and in the case of step down step up transformer, from lower voltage to higher voltage. So here see the diagram. Diode is going to be used. Here is the load, resistive load here is given. That is going to be the primary, the secondary. Now working of a half wave rectifier circuit. In this section, later understand half wave rectifier circuit transfer AC into DC. The term rectifier comes. It means you can surely say anybody that it converts. It may be half wave rectifier circuit. It may be bridge rectifier circuit. It may be full wave rectifier circuit. You can surely say anybody that it is going to be convert AC to DC. So what happened? The AC high voltage is applied to primary side of step down transformer. Just in the see the diagram. The obtained secondary low voltage is applied to the diode. The diode is forward bias. Just what I have told, diodes work in only forward bias condition. In the reverse bias condition, it does not operate. So it is called as a half wave rectifier. Because when the AC, what is the waveform if you are going to see the AC? Yes, suppose I am going to see in the diode. Here, see the AC. This is positive, this is negative. This is positive, this is negative. Right? So the pulsating DC output is going to be positive, positive. It means in this case, when this terminal is positive with respect to this terminal, anode is positive with respect to cathode, then and only then the rectification takes place, and this is good. In the next first half cycle, what happened? This is going to be negative. It means it is going to be the reverse bias. So here is no output. Again for the next cycle, again it will become positive. So it is going to be forward bias. So this is the pulsating DC output is going to be formed in the case of half wave rectifier circuit. See here in the diagram. This is the AC supply VNEFI. What output we are getting? Here. In this case, why not? Because in this case, the diode is in reverse bias form. In this case, it is in the forward bias form. So it is the conduction. So it is why we just call it half wave, because it is not converting full wave of AC to full wave to DC. It converts only half wave of the AC into, the waveform of the AC into the half wave DC form. So this is called as the half wave rectifier circuit. Now half wave rectifier capacitor filter. Why the filter is going to be used? Filter is going to be generally used to pulsating DC waveform into a transfer to a constant DC supply. Pulsating, it means suppose some harmonic or the distortion are going to be available. So for this purpose, capacitor filter is going to be used. Sometimes the capacitor filter is not in diagram, it is not seen. But when we are going to see the diagram, we are seeing the capacitor is connected. Why this capacitor is connected? To convert pulsating into a constant DC form. This is called as the function of the half wave rectifier capacitor filter. The capacitor diagram shows how a capacitor filter is used with half wave rectifier to smoothen out a pulsating DC waveform into a constant DC waveform. See here. This is going to be pulsating, that pulse, some pulses may be occurring. Then that is going to be removed and smoothen. That output of the rectifier circuit half wave is going to obtain. For this purpose, filter circuit or capacitor, generally capacitor filter circuit is used in this case. Now we will see what is the application of the half wave rectifier circuit. Here are few common applications of half wave rectifier. They are used for signal demodulation purposes. They are used for rectification applications. They are used for signal peak applications. And what are the disadvantages? Power loss, low output voltage. The output contains a lot of ripples. These are the disadvantages, and these are the applications of the half wave rectifier circuit. Here are few common applications. They are used for signal demodulation purpose. They are used for rectification application. They are used for signal peak amplification. And these are the disadvantages. And the first one is the power loss, second one low output voltage, and third one output contains a lot of ripples. So dear students, in this, when we are going to study the generation of the high voltages and current, in the first lecture we have seen, that what are the methods, what are that are going to be used for the generation of the high AC voltages, just like 2AC, what is the cascading, what is the cascade transformer, then what is the resonant transformer, what do you mean by resonance, then we also seen the Tesla coils. Tesla coils also we have seen that is going to be invented by the scientist Nikola Tesla. So it's going to be called a Tesla coil. Now in this case, what is going to be different? In this case, we are going to see the generation of the high DC voltage. So for these purposes, there is going to be used, that is going to be the half wave rectifier circuit, we have seen full wave rectifier circuit, voltage doubler circuit, cascade voltage doubler circuit. These are going to be used for the. So in the next lecture, we will see what is the full wave rectifier circuit. In the next lecture, we will see what is the full wave rectifier circuit. Thank you, students.